Okay, so the one subtle difference in today's lesson is that we are going to solve absolute value inequalities. So basically the exact same lesson, just this time around you're going to see less than, greater than, less than or equal to, or greater than or equal to in your original problem. So we are still in section 1.7. This is the last section before your quiz on Friday. So what I wanted to go ahead and do with you is just kind of a couple of things that are in our steps that still apply to today's lesson. And what I'm reminding you about right now is that there's almost like, there's step 1, step 2, step 3, yes, but above all, you're going to need to make sure that your equation is in the right form to start with. And that's kind of, what Andrea and I were talking about a little bit earlier. You're going to want to make sure that there's no coefficients in front of this thing or anything added to it. You want to make sure that your parent function, in this case the absolute value function, is isolated or by itself on that left side. Then you go into your steps. So then we go ahead into step 1, where you're going to break the equation apart into 2 separate equations. Then you're going to solve those equations, and yes, today you're going to have to check again in our lesson. So, and try this time around with these. Here, get to my slide. All right, so we are on example 2. I start with a pretty simple example to get us going today. It says solve the absolute value of 4x plus 5 is greater than 13. And then it asks us to graph the solution on a number line. Okay. Step 1 in the problem is just to basically make sure that we have our parent function isolated. So right now I don't see anything in front of my absolute value symbol. I don't see anything added to this inequality. I just see the parent function sort of all by itself. It's already isolated. So we have a decent form to work with. So it's at this point that I can go ahead and take a second and break the problem into two little mini inequalities. So we're going to do 4x plus 5 is greater than 13. So basically you write that first inequality by just dropping the uprights. The second inequality, and here's one little twist on yesterday's lesson. I'm thinking most of you in the room would be like, okay, well we got 4x plus 5 on one side, and then we have to take the opposite of that entire right side. The opposite of the right side in this case is the opposite of 13, which is negative 13. I'm going to ask you to think back to the warm-up yesterday for just a moment. Seems like forever ago. There's a little bit of directions there that said, remember when you multiply or divide by a negative number, you have to flip your inequality symbol. Does anybody know why we do that? Yeah, very good. Okay, so that's awesome. You don't do that because you're a robot. You do that because you made a change. Remember when you multiply or divide both sides of an equation by a negative number, you are switching the sign, the polarity, the plus or minus of whatever was on the right-hand side. You flip the inequality because you made a sign change. Well, people, in this second little inequality, I made a sign change. I switched positive 13 to be a negative 13. Anytime I just switch that sign on the other side of the inequality, I am responsible for flipping the inequality symbol to compensate for that sign change. So instead of having a greater than symbol, I have to write a less than symbol. So you might want to write yourself a little note. On the second inequality, remember to flip the inequality. And I'm just going to abbreviate inequality in equal. So just, that's your little note to yourself. If you're a person who looks back at your notes when you're doing your homework, and trying to remember the steps, you're going to want to maybe write yourself a little reminder that we did flip this second inequality, and we did that because of the sign change on that right side. So that's one difference between today and yesterday. There's really only if I had to pick like one other difference, and it's just in the way we communicate our answer. That's going to be a little bit different today. But, you know, step 2 is the same. I'm going to solve for x. It's algebra class, right? This is what we're going to do like all year. All right, so I'm going to subtract 5 from both sides. So I have 4x is greater than 8. And then I would divide both sides by 4, and I get 2. And then over here I would subtract 5 from both sides. Bring down my 4x and my less than symbol. Just want to erase this real quick here because it looks like a fraction bar and it's bugging me. Okay, there we go. So subtracting our 5 from both sides, I get negative 18. Divide both sides by 4. And I get x is less than negative 9 over 2. But because I'm going to plot this on a number line, I am going to turn it into a decimal. So now it says graph the solution on a number line. So I have x is greater than 2. You might remember that greater than or less than get open circles because I have to, you know, the solution set says x has to be strictly greater than 2. So I can't include 2 in my solution region, so we put an open circle there. And then it says greater than, so I need to shade to the right. As long as your variable is to the left of your inequality, you can always just shade in the direction that the inequality is pointing. So in this case, see how the arrow points to the right, so I can shade now to the right. And then I would want to put another open circle on the number that's between negative 4 and negative 5, and it says x is less than negative 4.5, so I need to shade to the left. And once again, as long as your variable's on the left, you can just follow the direction that your arrow's going there. This actually helps me figure out how best to write my answer. And what you're going to notice on your worksheet for tonight is that there's 2 ways to write an answer. So I just need to teach you, like, what are the 2 different ways we can write our answer. Well, what I see here is that x could be greater than 2, and that's a shaded region of my graph. And then I see another shaded region of my graph where x is less than negative 4.5. So it can be in one set or the other. Do you see what I'm saying? For that reason, I just have to write an or in my answer. So it's, just to review, it's either over here or over here. The other, for instance, we're going to see is where I shade in between the dots. Those aren't or answers, those are and answers, and we'll do an example of that in just a few short moments. So one of the ways we communicate our answer is to write an or in between. And this is if your arrows point, again, in the opposite direction. So my arrows were pointing in opposite directions. It's one or the other. I'm not done yet. I have to check for extraneous solutions, right? So let's do that. I need to check. Remember when you check inequalities, ooh, that's the highlighter. I don't want that. Remember when you check inequalities, you can't just like grab 2 in this case and shove it in there because 2 is actually excluded from our solution set. So what we want to do instead is choose a number in that interval. So for instance, 3 is a number that's bigger than 2. So I might check by letting x equal 3. And remember, we plug it back into the original equation. So in this case, I'm doing the absolute value of 4 times 3 plus 5. And I'm going to hope that that is bigger than 13. 4 times 3 is 12. 12 plus 5 is 17. The absolute value of 17 is 17. And 17 is greater than 13. So I know that this solution region is a good one. To check the other solution region, I just need to pick a number that's smaller than negative 4.5. So like negative 5. So we're going to let x equal negative 5. So again, I plug it into the original equation. So I'll do 4 times negative 5 plus 5 in my absolute value symbols, and I'm going to hope that that's bigger than 13. So I have negative 20 plus 5. That's negative 15. And the absolute value of negative 15 is 15. And 15 is greater than 13, so that makes me pretty happy, which means I know that that works also. So I've checked it, and we are done with that one. Real quick, I wanted to show you the case of and. Are there any questions on this example before I go along, though? No? Okay. Is it an or problem? And I should write my answer with the word or in it. If you're struggling to figure that out, what you need to understand is that that's going to go easiest for you if you draw a number line. So again, when the arrows point in opposite directions, it's one or the other. But this is normally like conclusion independent practice, but I just wanted to set up this part A for you real quick. Kind of show you how this is going to cook down. So again, I see my absolute value function is isolated. So I'm going to go ahead and break this absolute value function into its two little mini equations, or inequalities in this case. I'm going to do 2x plus 1 is less than or equal to 9. And then I'm going to do 2x plus 1 is greater than or equal to negative 9. Do you see how I flipped the inequality before I changed the sign on the right-hand side? And then I can solve each of these. So I'm going to subtract 1 from both sides, divide both sides by 2. So I get x is less than or equal to 4. Here I can also subtract 1 from both sides, divide both sides by 2. Remember, if you divide by a negative, you got to flip the inequality again. I'm not writing new rules here. So if this were a negative 2 out in front, I would have to reverse the direction arrow of the inequality again. But here I'm just dividing both sides by positive 2. So my inequality will stay greater than. And then on the right-hand side, because my sign is still negative, it's a negative 5, that inequality again stayed the same. Okay, questions about that? Okay, I want to draw this on a number line. It didn't say I had to, but I just want to make sure I communicate this effectively. So I have negative 5 somewhere down here. 0 is usually hanging out somewhere in the middle. And 4 is over here on the right side. If I shade to indicate my solution region, I would have a darkened circle on the 4. And then I would have a darkened circle on the negative 5. And do you see how I'm shading in between? That means that this is an and. But I need to be honest with you. In math, we don't really ever write solutions this way. Did you notice I shaded in between negative 5 and 4 for my solution set? I didn't check it yet. I still have to do that. But I'm just showing you how we're going to write what we think might be our answer. I shaded between negative 5 and 4. So I'm going to go ahead and plot my x between negative 5 and 4, and then include less than or equal to signs. That is how you're going to write your answer when it's an and. So this, in plain old English, says x is between negative 5 and 4 inclusive. And you'll see that on your assignments for tonight, they wrote them as compound inequalities. Okay, just two more things before I cut you loose on a little bit of independent practice. First thing we got to do is check this and make sure it's right. And I'll be honest, I like to take the easy way out of things every once in a while. I think most mathematicians do like to take the easy way out, good ones anyway. I need to check my solution region to make sure it's correct. So I'm just going to plug 0 into my original equation, or inequality in this case. I'm going to go ahead and plug 0 in, see if it works. If it works, we're good. By the way, I chose 0 because it's just a value in our solution set. It's right in between. So this is me checking. I'm going to let x equal 0. So I have the absolute value of 2 times 0 plus 1. And I'm just hoping that's less than or equal to 9. So basically I have the absolute value of 1, which is 1. And 1 is less than 9. So this solution does work. Okay, on your homework tonight, you're not required to graph on a number line necessarily. But if you're struggling to figure out, is this an and problem, where I should write my answer like this, or arrows overlap a solution region like they did here, that's where you're going to write your answer as a compound inequality. Last thing, notice, and this happens all the time, we write our answers from smallest to largest. We're going to write our domains in this way in chapter 2. So you see I started with a -5 and stopped at a +4. So your answer always goes smallest to largest. And you'll see that, they give you the answers on your assignment sheet. You'll see that the numbers go smallest to largest. That's not like a rule I make, that's like a math thing. Okay, so now you get to try a couple. Go ahead and give it a whirl. See how it goes. Hopefully today's lesson helped a little. I did take a second to just post your answers there for you. So do take a second to check them. And then you can holler at me if you have some questions. You just have the back of the famous old dudes worksheet for our homework this evening.